from my computer, I have this bot code. This is the Defi Arbitrage bot that we are going to use in this strategy of finding potential arbitrage to execute. You can clone this directory from the GitHub repo, link in the description. And if I click on the source directory and then open the main.ts, which is the main file, from here we have the imports that we require to run this our main.ts. More on these imports as we are proceeding. From here we load our environment variable, which is this .env variable. If I open my env file, from here I have my minimum price different percents. This is the minimum percentage in which the price is different from each exchanges before your bot can execute arbitrage. If you want to know more on how this minimum price is calculated and the price difference, there's going to be a video tagged to this video right now and in the description of this video. Watch that video to learn more on how arbitrage can create a price difference from different decentralized exchanges. This is the RPC WebSocket URL. Take note that this is my personal node that I am running for personal development, so this might not be available, so I am just giving it for you for free. You can use some node providers like Alchemy, or if you have your own node, you can also put it in here if this one is not available, because this my node might not be available in the future. And here is where you are going to paste your private key. From the data we have in our .env file, we are going to load it here so that this our environment can have access to the variable that are in the env file. So that's what we are doing here. So we process the RPC URL, that is the WebSocket URL, the private key variable. We are going to store it here by loading the .env file that we have here. Here we create a wallet variable, and here we create the provider variable, which we are going to assign the blockchain URL. This is the connection to the blockchain that we are working on, in this case base blockchain. And this is where we are going to assign a data to this wallet variable, which is going to be, if you are pasting private key from your .env file, we are going to assign it here. But if you are pasting your seed phrase, then we are going to assign it from that seed phrase. And we have a wallet instance here. This section is the configuration file of your bot. So the settings, which is the setting type, in which if I go to the setting types, you are going to see it has a minimum price different percentage number and the RPC string. The type of wallet is ethers.wallet and the provider is ethers.provider. And here is where we assign all our settings parameters to this settings variable, which is an object. So have that in mind as a settings. From here we instantiate our module class and assign it to this bot variable, which will do the functionality of our bot. From here we have a run function, and from this run function we have bot.initialize, in which if I navigate to the definition of the bot.initialize and then maximize it, you are going to see the tags of this function, which is to get the allowance of a wallet that is linked to this bot via the .env file and the balance. After that, we are going to confirm if the balance is less than this amount. If the balance is less than this amount, that is the WETH balance, then we are going to output a message that the wallet has a low balance and exceed the code until the wallet is funded so it can execute arbitrage. And after that, we are going to check the allowance of the wallet. Allowance is a check to confirm if your wallet has approved a specific contract to execute trade on behalf of it. So from here, if the allowance is 0, it means this bot does not have permission to execute trade on your behalf. So that is, if that's the case, we are going to grant the bot permission to execute trades on your behalf by increasing the allowance. And when we are done, we are just going to console.log that initialization completed. This check is only run once you start your bot. And from here, this is where it gets interesting. You can see from here, this is the provider that we assign as a blockchain. So consider a provider as the whole blockchain that we are working on. So this provider will have a function to check what is happening in the blockchain. In this case, we are listening to events of the base blockchain, which is the block event. So anytime a block is added, we are going to see in our code that a block is added, and we are going to get the block number from here. Let's confirm it by console.logging the block number. So I'm going to console.log this block number and then process.exit the code. I am going to ts node main.ts to run the file. You can see it is initializing and it completed. Currently now you can see the current block number that is being added. If I did not exit the code, it will keep on showing the block number that was added. In this case, I am going to comment out the whole code and everything underneath this, so the code will not keep running, but rather it is going to print all the block numbers that is being added. So let me run the code again. You can see once a new block is added to the chain, it is going to output the block that is being added. Currently now, as long as this block is added, we are going to scan for potential arbitrage for all the transactions that is in that block, because swap transactions is our target. Okay, so now our bot is going to consider a swap transaction as a ripe mango, in which it is going to target to find out if it is worth getting the mango, which is if the arbitrage is worth execution whenever a swap happens on this block. I am going to Ctrl C to stop it and then copy this latest block that I've stopped and then navigate to basescan.org, and then from basescan.org I'm going to go to blockchain and then go to few blocks, and then I'm going to do Command F to search this website and then paste the block number. And here you can see the block number that our code found. We can see there are 78 transactions in it 31 seconds ago. Okay, so I click on it and you can see our code was able to find this block, and that is exactly what this function is about. The next thing is that once we get that block number, we are going to get the properties that is in that block by calling the provider.getBlock and then passing in the block number. Let's see what are the properties of that block by console.logging this block that is being added, and we are going to exit the code. So I'm going to run this, and you can see the properties for each of the block that is being added. We have the block number, the block hash, as well as its timestamp and every other information. From this point, we are going to go through the transaction properties. The transaction property is like a list of all transaction hash in that block. So we are going to loop through the list, and then for each of the transaction hash, we want to do something for that transaction hash. So from that transaction hash, we are going to call provider.getTransactionReceipt to get the exact transaction receipt, because it's the receipt that will tell if that transaction was a swap transaction or any other transaction. We pass in the transaction hash and then we get the transaction receipt. So let's console.log the transaction receipt and see what it looks like. Okay, so now this is a transaction receipt. Whenever a transaction is being sent to the blockchain, there's going to be a receipt like this that is being generated for each of the transaction. This receipt is what you can find in the block explorer. For example, if you are doing transfer from one wallet to another, and anyone can see your transactions, that is amazing. So let's find out the transaction in the block explorer by copying the transaction hash and then navigating to the block explorer. Paste the transaction hash and we are going to find out which type of transaction. Yeah, great. This is a swap transaction. You can see that this guy swapped 219 USDT to wrap ETH, and this is the kind of transaction in which our bot is going to hunt for. After we've gotten the transaction receipt, we are going to pass the transaction receipt, which is this data, into this process transaction receipt. This is the function that is going to execute the arbitrage if this transaction causes a price difference. For example, if it was a swap transaction and the swap transaction impacted the price in this specific pool that the transaction occurred, and then from scanning other exchanges, we find out that the price has changed. It has depegged from other exchanges. So what our bot is going to do is that it's going to send a transaction automatically to execute that opportunity. Let me navigate to this process transaction receipt and then go to the divination. and from here, which is our module class, we can see our process transaction receipts here. So I'm going to maximize it, and then this is the transaction receipts that we pass in. If the receipt was not there, we are not just going to do anything, but if the receipt is there, so we are going to go through the transaction logs, which is whenever a transaction like this is being sent to the blockchain. For example, in the case of a swap transaction like this, you are going to see logs. We have the logs here, like this is log number 1, this is log number 2, and this is log number 3. So that is exactly what we are going to find here. I am going to console.log this transaction log so that we can see how the transaction logs look like. So for each of the transaction that is added to the block, like these are the many transactions that is being added, we can see that some transaction might not have a log because the smart contract does not emit any events. But in the case of the transaction that has a log, which is a swap like transaction, you are going to see this topic, and this topic is where our interest should be. Now let's navigate to our transaction, and if you go to transaction, you are going to see topics here. Like this one has 1, 2, 3 topics, of course. And when you go to swap transaction, swap transaction has 3 topics as well. This is number 1 topic, number 2, and then number 3 topics. This topic is a byte-like representation of what type of event was emitted. So it's just like saying, take this swap function signature and then encode it to have a byte-like representation. So this swap is what is representing here. That is this swap signature. We have a swap call, and in this one we have a transfer signature, and it is represented in a byte-like format. So that's why we are seeing topics. And the next thing we are going to be interested in, as I said, is the topics. Remember that this is a log number 1, log number 2, and 3. So transaction can has many logs based on the nature of the transaction. So that in the case of this one, it has only 3 logs. So we are going to go into each of the logs of the transaction. That's why we are saying transaction logs dot for each of the logs. So it's like saying from this one, and from this one, do a check. So that's why we are having transaction log, and for each of the log that we are checking, we are going to check the topics, and we are saying for each of the topic, which is in this case, this one has 3 topic, 1, 2, 3. So we are going to say for each of the topic, we are going to check if that topic is equals to Uniswap v2 fork post swap signature in byte format. Remember, the signatures are not represented in normal function signature, is represented as bytes. So that's what we are doing here. So if we go here and then we go to the definition of this, you are going to see Uniswap v2, that's a v2 protocol, any Uniswap v2 protocol swap signature. That's for each of the Uniswap pool, we have a swap signature that emits events for each of the pool, being WETH Uni or WETH any other token. This is the function signature that performs the swap. So whenever you make a swap, this is the function you are actually calling on the pool contract. We are going to encode that function into a byte, which is this type of Kaket 256 bytes. So that is why we are passing in this function signature and say we want it from UTF-8 bytes like value, which is readable, human readable value, but we want to convert it from that value to a byte-like value in which our blockchain is going to recognize, in this case Kaket 256. So let's console.log this and see what it looks like. You can see it from here. This is what it looks like, and I am going to copy it and navigate down here and then do Command F to search the data of this page, and you can see this is a Uniswap v2 signature, and this is the byte-like representation of this signature. So we can use the byte-like representation to know if this transaction is a Uniswap v2 swap or if it is a Uniswap v3 swap. So this is the topic, and that's exactly what we are doing here. So if we go down here, we convert all the topics, which is for each of the topic that we are looping, we convert to lowercase and then perform some logical check to see if that is the same with the Uniswap v2 pool swap signature in bytes, or if that is not the case, we check if it is for Uniswap v3, and this is for Uniswap v2, this is for Uniswap v3. That's exactly how it is. Down here, what we are going to do next is that if this is a Uniswap v2 like exchange swap transaction or signature that we got, we are going to say lock.address, because this is a swap lock. We are going to assign the lock address to this pool address, which is going to be the pool address. In this case, this is the lock address. And if I copy this and then I'm going to duplicate this and then search the address I copied, you are going to see that this address is a Uniswap v2 like pool, and you can see here Uniswap v2 pair. And if you go to the read contract section, you are going to see the methods of this pool. Like in this case, you see the token 0 as well as the token 1 and so on. So this is WETH and that token that was being swapped. And if you go to the write contract section, you are going to see this is the method that performed the swap, which is the swap method, and it emits the events in which we are looking for in our log. So we have gotten it and we save the pool address here. And the next thing we are going to do is that we are going to create a contract instance of that pool. That's why we have pool contract. So we have the contract instance here. And from that contract instance, we are going to make a promise.all call to get token 0 and then token 1. So if you go to the pool again and then go to read contract, you are going to see here token 0 and token 1. So this is what we are making a call to find from that pool contract. We are finding the token 0 and then token 1. We save it to this list of token 0, 1, and then we then pass in that token 0, 1 list and pass in wet address. So from this address, we have a WETH address, which comes from this variable which we loaded from our address.yaml file. So we have our YAML file here, in which has the contract address of different decentralized exchanges with which we are going to arbitrage, and it also has our WETH address here in base chain. This function checks to confirm if that pair that the swap is happening is paired with WETH. If it is paired with WETH, this function is going to return the token address and the WETH address, else it is going to return none. So if it returns none, we are going to do nothing because the pair is not paired with WETH, but it's paired with maybe XYZ USDC or any other pair that is being paired with. But if that's not the case, if it is paired with WETH, we are going to call this find pool index, and the same thing is applicable to Uniswap v3 if that swap was captured for Uniswap v3 by using the swap signature byte to confirm, just the same way we confirm for Uniswap v2. And then the two function calls, these two check call the same function, which is this find pool index, and then we pass in the transaction receipts, we pass in the pool address, and then we pass in the target token in which we are going to arbitrage, which is going to pair with weights. This is an array of token address and the WETH address. We pass in the pool address. A quick overview is that this find pool index is a function that is going to see if this token that is being swapped is available in other decentralized exchanges. In our case, all these decentralized exchanges that we have here, like Uniswap v2, Uniswap v3, as well as Pancake v2 and v3. We also have SushiSwap v2 and v3, BaseSwap v2, and you can go ahead to add any Uniswap v2 or v3 exchange in this list. But make sure that these exchanges that you are adding doesn't have any extra function or any extra function signature that is different from Uniswap v2 or Uniswap v3 Fox exchange. Right now, I am going to minimize this and maximize this find pool index, which is the function that is being called from this process transaction receipts. This find pool index takes in an array of the token as well as WETH, and it takes the mother pool. Take note that the mother pool is the pool address that is being captured from the swap. We are going to refer to it as a mother pool inside this find pool index function, and the token find is going to be an array that include the token that we found and the WETH addresses. In this function here, you can see dex factory. This is the list of all the dexes that we have in our address.yml file. So if you can check it now, you can see we have the factory address and the version of that dex. So this is PancakeSwap v2 and we have PancakeSwap v3. So this is, we are structuring this in a array in which our smart contract can recognize. So we are going to pass this dex factory into our smart contract, and then the smart contract is going to scan the blockchain to see if those token that is being swapped is available in any of these exchanges. If it was unit token that was swapped in Uniswap v3, for example, it is going to scan other exchanges to see if unit token is also available in it. So that's what we have here, the list of other decentralized exchanges. Think of this as the interaction with other DeFi protocol like decentralized exchanges. And after that, we have our smart contract call, which is the getter contract. The function of this contract is just to get the pool properties that we pass in from the dex that we pass in, which is in this case our addresses, the dex that are here in our addresses.yml file. So then we pass in the dex factory that we are going to search this token, and then we pass in the token that we found, which is the WETH and the token address. And then we pass in the minimum liquidity, which is 1 WETH. So if that pool doesn't have up to 1 WETH in the liquidity, it means this bot is going to ignore that pool because the liquidity is not enough for us to arbitrage. This function is going to return this type of data, which is going to be an array of array that include another array of the pool properties, and then we are going to get the decimal of that token from this function call. So this is the base token decimal, we assign it here, and the pool data is what we assign it here. So from the pool data, we are going to filter pool that does not equals to 0 address, because if it is a 0 address, it means that the pool is not available in that exchange. So whenever this smart contract call is being called, whenever this get pool method is being called, it goes to the exchanges to see if this pair is available. If it is available, it is going to return the pair address. But if it is not available, it is going to return 0 address for all the exchanges that we pass in. This token decimal is going to be in big number format, so we convert it to normal number, and then we have the variable here. So currently now, after we filter the pool array to only pool that is not 0 address, we have the pool array here. And we are going to check to make sure that the length of the pool array is not less than 2. If it is less than 2, it means the token that is being swapped, it's only available in one exchange. In that case, we can't arbitrage that token. But as long as the pool is greater than 2, which is the pool that is being returned from this get pool method, it means that token that is being swapped or that pair is also available in other decentralized exchange, and that swap might cause the price to change, which is what we are excited to see. I am going to console.log the pool array so you see what it looks like here. Okay, so this is it. Now we can see the result. Like in this case, this token that is being swapped is available in 12 exchanges. The return value of this get pool is what we have in our type, though we have not utilized it. So this is it. So it's going to return the pool address. In this case, this is the pool address. It returns the WETH liquidity and the token liquidity, which is this, and then this, and the DEX version, which is this. In this case, Uniswap v3. If it is Uniswap v3 is going to return the pool fee, which is 500, which is 0.05, and it's going to return the square root price x96 for Uniswap v3 pools, which we have it here, and it is going to return if token 0 is WETH. Like in this case, token 0 and token 1. Token 0 is WETH. The reason why we are returning this is because we are going to use this when calculating price of the Uniswap V3 pools. Now this is one pair that is available in a decentralized exchange. This is another pair that is available in decentralized exchange. Okay, so we can see this pair is available in 12 exchanges on base blockchain. I am going to copy the pool address and then navigate to Dex Screener or Dex Tool. Let's use Dex Tool for example of this video. And then I'm going to paste it here, and then we see that the pair is WETH USDC. Like in this case, we can see that that pair is in PancakeSwap V3. And if we copy another address, for example, and navigate to Dex Tool and then paste, we can see the same pool, which is WETH USDC in SushiSwap V3. Here, what we are going to do is that we are going to design an array, a variable of an array that will include the mother pool from the return of this pool array. So the mother pool, remember, the mother pool is the pool that was captured from a swap that was added to the blockchain. So we save it here, and then other pools, that is the other pools that are going to be available for arbitraging, we are going to then save it to this other pool array. So this one will include other pools for other decentralized exchanges. So the way we do that is that we are going to loop for each of the pool that was returned from this get pool method of the getter contracts, and then we are going to go into that pool array that is being returned and see if the pool is equals to the mother pool, which is the mother pool that is being passed in here. Then we assign the mother pool array to the pool array, which is the data on this pool array. It might be any index in it, which is this. But if that's not the case, we are going to assign it into this arbitrage pool array, which will include all other pools, which is this properties that we have here for other exchanges. So we are going to add it here, isolating the mother pool, which is the pool that we are going to arbitrage with other pools. So we are done with that, but we are not done with all. What we are going to do is that we check to make sure that the mother pool is available or is returned from the getter contract that we call. This is just a check for confirmation because we already passed in the pool and we just want to make sure. Okay, so this is where we are going to calculate the price of the mother pool. Okay, so how we do that is that we check from the mother pool array that we have. The index 3 is the DEX version. So remember, from our type, this is the DEX version. Okay, and then once we check if the DEX version is equals to Uniswap V2 protocol exchange, and we are going to call calculate price for V2. I am not going to go ahead to explain how to calculate these prices. You can check the function on your own to find out how to do the calculation, because the calculation for Uniswap V3 and Uniswap V2 is different. And if that's not the case of Uniswap V2, we are going to say, yeah, that's Uniswap V3. So we are going to call the calculate price for Uniswap V3. And this calculate price function takes in WETH liquidity and token liquidity of the pool in which we want to calculate the price, and also takes in the token decimal. From here, we are going to calculate the price of the other pools to arbitrage. Remember, mother pool and other pools to arbitrage. So we have gotten the mother pool price here, and we want to see other prices from other exchanges. So that's what we are doing here. We are going through the other pools array. For each of the other pools array, we first of all going to create an arbitrage pool prices, which is going to be an array that include all the prices of other exchanges with their index. So we are then going to say for each of the pools that is in this arbitrage pool array, we get the pool liquidity in WETH, in token, as well as the version, the square root price x96, as well as if token 0 is WETH. And we get the values of that and then save it into this variable because we are going to use it. And then we say price of that pool is equals to the same thing that we did here to calculate the price from other pool, and we do the same thing here. And this time, after we calculate the price, we then are going to assign it to the same index. The first index of the arbitrage pool array is going to be the same index, which is the first index of the arbitrage pool prices, because we are looping through the arbitrage pool array, and then for each of the price that we calculate for the loop, we assign it to the same index in this. So we are going to use the same index to know which price belongs to which pool in the arbitrage pool arrays. And when we are done with all the calculation, we are going to find the highest and the lowest price in the arbitrage pool prices. So from this array, we are going to find which one has the highest price from all the exchanges and which one has the lowest price. So that's what we are going to do here. So we then call this function, which is find highest and lowest. What this function does is that it takes in an array of numbers and then return the index that is the highest and the value, and then return the index that is the lowest and the value for that. So that's what we are going to have here. So this is going to be the highest value and the highest index. So we have here highest price and then the index of the highest price in this array, and then lowest price and the index of the lowest price in this array. That's what we have here. We then have which exchange from the list of all other exchanges that this token is available, which exchange has the highest and the lowest price. Okay, so after that, we are going to compare. We are going to find out in summary which pool has the highest and the lowest. Is it the mother pool or the arbitrage pool from the list of the two prices that we have from the other arbitrage pools? So that's what we are going to do here. So we call the find highest and lowest. This time we are going to pass in the mother pool price, which is this price, and then we pass in the highest price of the other pools, and we pass in the lowest price of the other pools. And what is going to return is going to return from this mother currency and this higher price and lower price of other pools, which one is the highest and lowest. Is the mother pool price higher or lower than this? Then we are going to decide if we are going to buy from mother pool and sell in this pool, or sell in this pool, or if we are going to buy from this pool and sell in mother pool, or buy from this pool and sell in mother pool, based on the price that is high or the price that is low. And then we assign it to this router variable, which is routing how we are going to route our swap. So we then have the lowest index and the highest index. So this is where we are going to buy low and then sell high. So we then declare a variable buy low, which is going to have a dex factory return property, which is the type of which I show you here. And then we then have the buy price as well as the sell price for that specific route. And when we are done here, we are going to assign these variables. So we are going to go into the lower index here and then see if that lower index is equals to 0. It means mother pool is the lowest. So we are going to assign the buy low to mother pool and then buy price to the pool of the mother price. But if that's not the case, if it's equals to index 1, it means it is the higher price, because remember that's the return value from the router, which is lower index and higher index. Okay, and that's what we are doing here. We then check is the lower index equals to index 2, which is this index, and then that is going to be our lower price. We then assign it to the buy low and the buy price, which is going to be the lower price. And we do the same thing to find the highest, which is where we are going to sell high, and then we assign it to this variable as well. That's what we are doing here. And once we are done with this, we then have a variable that has the price that we are going to buy and sell, which is buy low and sell high. Then we come here and calculate the percentage of the price discrepancies by using the price difference, which is the sell price, the highest price minus the lowest price. Okay, so once we get the price difference, we then utilize our function, which is percent of x and y. Once we pass in the price difference, which is going to be x, we find out what is the price difference of the sell price. So we are going to then see the price difference, and this is going to be the price difference of two liquidity pools. It might be 1%, and that's exactly what you put in your settings, minimum price difference. We are then doing a logical check here to see if the price difference is less than what you put as a tolerance in the settings file, which is the .env file. Then if it's less than that, we are not going to do anything. But if it is not less than that, it means it's greater than that, and your bot is going to proceed. So what we are going to do next is to calculate optimal trade volume. I am not going to go into details on how to calculate optimal trade volume, but in case you are interested to know how this calculation is done, there's going to be a tag of a video that explains this right in this video right now and in the description of this video. In a quick overview, this is what we are going to use to calculate how many ETH do we need to fill that price gap that is available. So this function is going to calculate how many WETH we need to fill the price difference that is available. Remember that arbitrage, but it works unify the price. So your bot now is about to unify the price discrepancies. So it needs the quantity of amount of ETH that will impact the price to the point it is going to unify with other decentralized exchange that the price has become different based on swap. Okay, once we are done with that, we are going to encode a function call. The reason why we are encoding it is just to pass a single data into a smart contract call just for fast execution. So we are encoding it to a byte, which is the function execute swap.extract, which is going to call the smart contract to execute your trade, which is buy low and then sell high. So what we are doing here is that we pass in an array of the pool that we are going to buy low and then the pool that we are going to sell high. Remember, this is index sensitive, meaning that you have to pass in the pool that you are going to buy first before the pool that you are going to sell. So it buys low and then sell high. So we pass in here, we pass in the version, and from the sell high properties that we got here, and then we have our extract array in which we are going to pass into our smart contract call. So we are encoding it here. The trade part is here, buy here and sell here, and the token find, which is the target token, and the amount that we want to buy, which is amount in WETH. And then we encode the function here. This is the function signature that we are encoding. So then what we are going to do next is to call this function to execute the swap, which is this.execute swap.extract. The extract is like saying MEV, which is my maximum extractable value. So we want to extract the value from the blockchain and make it to unify the price from here. And then we wait for the transaction, and when we console.log transaction executed with the transaction hash. But if that transaction was unable to execute, maybe the smart contract call failed before sending the transaction to the blockchain, then we are going to print the error message here. This is a quick overview of the code of these bots. Do well to click on the subscribe button and put it in the comment section if you have any question about this specific code, or during the time you were following the code, if there's something you don't understand, or when you are going through it yourself. Do well to put it in the comment section, and also remember to join the Discord channel. Link is going to be in the description. Until then, see you in the last part of this how to make your own arbitrage bot video.